It's a great honor for me to moderate this session where we will speak about big data, fair data, and open data issues. Uh, we have um, we have a list of great speakers today. So we expect that we're going to have short presentations, 10 to 15 minutes. And then hopefully we'll have some time for the discussion because we actually already started this discussion and it was hard to stop. So let me introduce to you our first speaker today. Professor Barend Mons, President of CODATA, Committee on Data of the International Science Council, co-organizer of this wonderful conference. He is also co-founder of the GoFair initiative and professor at Biosemantics in Leiden University. So please, Barend, online stage is yours.
Thank you very much. I will call indeed a few slides, but it's part of a much larger presentation. Don't worry, I will be shorter than 15 minutes. So thank you very much for inviting me to say something about fair data. And you know, I'm the last author on the original FAIR paper, which was now cited well over 4,000 times. And we always have our internal joke that half of the people that cited the article never read it. And that is when something becomes a hype term. And even my CTO, Luis, who is more cynical, says that half of the authors didn't read it. So we really have to get down to what FAIR really means. And it's abused a lot at the moment that people call anything fair that is findable and open. And one of the things I would like to say is that fair is not the same as open. We will come back to that. So what we actually now do to implement FAIR, also in very practical things like the COVID crisis, is that we say if data are big, too big for humans to handle, we need to make them machine readable and actionable. We need to make them as open as possible, but of course also as closed as necessary. As Alena said, I'm a professor at the Leiden University Medical Center. Of course, we cannot make our patient data open, but they're extremely important to be visited and reused to better beat the COVID crisis. For example, I'm in the middle of this now new term, VITT, the vaccine-induced thrombocytopenia, which is the so-called side effect of the vaccines. We don't even know yet. And there is this massive influx of data. And do we stop the vaccination or not? We need, this is already big data. So in a way, because we have to connect it to a lot of other data. So what I really want to emphasize that I now summarize the 15 FAIR principles as machines know what it means. As long as machines can understand the data and they can see them as packages that are ever larger and larger as a containerized approach, then we enable machines to become our slaves to do big data analysis. But again, data, even if they cannot be open, should still be fair if possible. And not all data can be made fair. And obviously, it's also very important to emphasize that fairness is not a goal in itself. It serves AI and distributed learning, even to the point where on the Vodon website, the Virus Outbreak Data Network, I will actually switch there because I have the slide here, I see. And that is that the Americans found a nice other meaning for fair, federated AI-ready data. That's fair again. So basically, if we want to use the computer as our major assistant, we need to make everything so that machines know what it means. Now, of course, machines know nothing and they're stupid, but you know what I mean, I suppose here. Now, I will go into a little bit more detail about that and then say how we have to do this globally. But before we go there, the reason why this is so important in the context of this conference, that's all about systems analysis. For each of the sustainable development goals, as I said in the opening session, we have to cross disciplinaries. We have to cross regions. It is a system. It is so complex that nothing from climate to health to whatever water quality is a single disciplinary thing. And the thing is, if you want to cross disciplines in terms of data, your data stewardship and interoperability problem jumps an order of magnitude in difficulty. Because in each domain, they use different thesauri, different terminology, false agreements, false disagreements. Machines are driven crazy by our sloppy way of dealing with data. So coming back to the core, I will only show this slide and the next one, and that's it. Essentially what we said, and this is now a global consensus, and this is almost like in the center of the hourglass here, like TCP/IP and the internet. Um, every single data element, no matter how small, starting with a single identifier, but then a triple, a graph, a database, anything, should be a so-called fair digital object. There is, of course, a record like a triple or a single identifier or anything. That should have a type, so the machine should be able to answer three questions. What is it? What is the type? Is it a triple? Is it a graph? Is it a relational database? Or whatever is represented here, what can I do with this digital object? That's a technical question which we will increasingly have in a type registry and an ontology to say, if it is a triple, these are the technical handlings you can do as a machine with a triple. Don't try to do something with a triple that you can only do with a relational database, of course. But very importantly, and that comes to the second point, fair is not the same as open, there is what is allowed. So every single digital object, even for example a nanopublication determining a variant in my genome, one of the hundreds of thousands, should have a license. So a very important point in fair digital object is that you always separate the metadata from the data. So this metadata file is a fair digital object in itself. It has a different type, and it says I am the metadata of this thing, and this thing says I have metadata there and there. And there could be hundreds of metadata files associated with one digital record. It's going too far to go into details. The final thing to say about it, technically, and you see how simple it in fact is that every container, even the entire internet, but you could say a whole graph or a big database, but even a single assertion, like a nano publication, should have what we call now a globally unique, persistent, and resolvable identifier. And the resolvable is extremely important for the machine knows what I mean, because if you have a globally unique and persistent number and the machine cannot resolve it to its meaning, it's still useless. So as long as we build up the entire system from fair digital objects, larger and larger containers of it, they can act as the switch, as the packages in the current internet. Finally, they can point to another digital object, like you see here, the metadata, say I'm the metadata of this digital object. But this could also be the description of a tumor in a biobank, or a butterfly in Naturalis, or another digital object. So we now make, for example, in Leiden, for every tumor that comes into the hospital with the patient in the Leiden Center for Computational Oncology, we make a so-called fair digital twin of the tumor, which is a fair digital object. Everything that's knowable about that particular tumor is there in machine readable format. That's enough about the technology. One final, final thing to say. There are 4 major international organizations that deal specifically with data. That is CODATA and COFAIR, and you see behind me I'm involved in both. Then there is of course RDA, which I'm also sort of involved in, and the World Data System. And we now created this common statement called Data Together. You can find it on the website and also on the Vodon website everywhere. And we defined our respective niches, and you can see them here. I'm not going into any details. And of course, there is overlap between all of them. So to make this happen at the global level, at UNESCO level, so to say, we need to work together to have the ideas, to make them standards, to test them out in GoFair, and to store them well in, for example, Core Trust Seal repositories. And all of this is needed to enable big data, open and fair data-based systems analysis. So I would like to leave it there as a setting of the scene. The definitions, fair is not the same as open. Fair is not a goal in itself. And very importantly, as a last point before I stop, and that is, we should stop sharing data. And now I'm always waiting to see the shocked faces at the other end say, oh, stop sharing data. Yeah, because if you say sharing data, people think I sent my data to somebody else. I lose control. Maybe I cannot do it because it's patient data in my case. We move from data sharing to data visiting. So we send the algorithms, which are also infinitely smaller than the data itself. They're gigabytes rather than petabytes, to the data. So people keep control of their own data. They allow virtual machines to come in and to study their data and reuse them without ever, unless absolutely necessary, moving the data out of their original place and under the auspices of their original custodian. So the data of our patients will never leave the hospital, but they can be visited by everyone we allow to do so, and by every machine. So, Leona, I think I should leave it there and hope that others will put more stuff for discussion. Thank you.
Barend, thank you very much. Actually, that was the best way we could start this discussion and to start this session. So I'm happy that I skipped my first introduction because you made it so better than I could. So our session is just to mention to all our honored speakers that it is broadcasted at the Moscow in Mises University, and it is also recorded. So if I will see any questions from the audience, I will translate it to you. But anyway, there are so many people on YouTube watching us now, but we will try to keep this path. So actually, I wanted to ask some possible questions before we continue. So we're now speaking about fair data, about open data, as well as about big data. So, and I think that even at the beginning of our conference, we've been asking for the best way to make it happen on a high level, as you mentioned. We all know that where it's not possible, and you're absolutely right, that it is not possible to make all the data open. So we're not probably trying to get to this kind of future because, I mean, it's still shocking when you ask people not to share their data, but the visit data. But I think it's a very right way to make this happen, actually, to make open data, even if it's not open, but fair enough. So, and my question will be about big data. So do you think that the big data could be fair enough? And are we trying to get to the future where every big data set is AI ready, and if it's possible?
Yeah, well, let me say two things, and I'll try to be short. This is a quote of my guru, George Strawn, who started as an NSFNet and the internet. You know, his statement for the long-term future is, the internet brought us from many computers and many data sets to one computer and many data sets. You know, all computers are connected. He said, fair has the potential to bring us to the situation where we have one computer and one data set in the world. Still, some segments of that data set may not be open. That's another story. So that's one thing. On all big data being fair, a lot of big data are intrinsically, to a certain extent, machine readable because they were created by machines, they have a pattern and so on. I think what we are always forgetting, and if you go back to the FAIR principles, you will see that virtually all of them are about metadata. The same George Strachan said, we will end up with more metadata than data, which sounded to me like another crazy statement. But the reproducibility crisis that we face today is not at all related to, or not at all, for a small percentage related to bad science or bad conclusions. But the fact that we cannot reproduce other people's results is usually due to the fact that there is not enough metadata and provenance to know exactly how they did it. Even in workflows, or data science workflows. Oh, you used another version of my workflow. Yeah, I never bothered to tell you which version I was using. So these kind of things is really important, that we need metadata first. Always think about your metadata. And even if your metadata say, by the way, the data are in a stupid Excel sheet, you cannot use them as a computer, or they are pictures in DICOM format that you can learn on as a machine, as long as machines know what the data means and how they can process them, I would consider the metadata fair. And the data do not always have to be fair. And also, finally, on the legacy data, that everybody say, oh boy, think about all these legacy data that we would have to make fair. No, two things. One, 90% of the data we have today in the world, which can be still stored in 1 kilogram of DNA, but okay, all the data, 90% has been created in the last 2 years. And this will be true again in 2 years from now. So much for legacy data. Of course, we need to make some of them fair. So my statement is, only make legacy data fair the first time you want to feed them to a machine.
So just to add to this, I think that we're still living in a world where 90% of research is resulted in the way of PDF publication. Does that mean that 90% of scientists are doing bad science, or and how we can make this switch? So
let's first move on to the other speakers.
Yes,
I have a strong opinion here, but for later.
Yes. I can wait to hear our discussion at the end. So let me here present our next speaker, Shamila. She's Assistant Director General for Natural Science, United Nations Educational, Scientific and Cultural Organization, UNESCO. Shamila, take your time, please. If you have your slides, we're happy to see it.
Thank you. Thank you very much, Alena, and good day to all of you. It's a pleasure to see all colleagues and friends again, like Baron. It's a pleasure to meet all of you again on a very important item, especially at this point in time. So we as UNESCO, we're delighted to join this forum on big data and fair data, open data. And I think we're at a crossroads in society today in sharing this kind of information. And especially today, I would like to thank, on behalf of UNESCO, the National University of Science and Technology, Mises, but I also want to thank the Russian Foundation for Basic Science, Russian Academy of Sciences, and also the Austrian Academy of Sciences and the International Institute for Applied Systems Analysis. I think this is the first time UNESCO has been invited to an event like this. So I was delighted to hear Baron just now, and I'm going to ask him a couple of questions on his data visiting versus data sharing. And I would put an additional word, which is called data using, because I think just visiting may not be good enough. It would be important to understand how it's being used at some point. Now, we all know that UNESCO was established after the ravages of the Second World War. And as stated in our constitution, since wars begin in the minds of men, it is in the minds of men that peace can be constructed. And so today we need to consider our role towards equal access, and I would say, Baron, sorry, knowledge sharing, knowledge visiting, if you would like. Knowledge visiting, I put it that way, yeah? And I would put an additional word, which is knowledge and data capturing. because how do you want to capture it and use it thereafter? So I'm going to try and share with you my slides, if I may. Share the screen. I'd like to share with you a couple of thoughts and ideas, and very much so that the indicators of the Sustainable Development Goals are all very much linked. I don't know, I have a problem to share this somehow.
You're not available.
Can you see it now?
Yes, we can see it. It works. Thank you.
Okay. Let me try and get to the first slide. Yep. And I'll get here. So I think I would like to share with you a couple of ideas and thoughts on why UNESCO is pursuing a recommendation on open science for global research and for fair data. So what kind of science do we need, and what kind of data sharing do we need to fight inequalities? And I think Baron mentioned that we need to have access to this, yes, and we need to look at big data, but how to process this, and what kind of collaborations would we need for that, and how would we enable then our communities to actually use this data to promote science policy society dialogue. So I think for us, what would be important is to consider what type of an enabling environment would we need for the context of fair data, what conditions for this inside, within organizations and outside organizations. And I would like to share with you then why UNESCO has embarked on what is called the open science. So open science because of the S in UNESCO, because of the SDGs, because of the Article 27 of the Basic Convention on Human Rights, that is the access to developments in science and technology, but also the convening power, and because of the normative power of UNESCO. So in 2019, the General Assembly of UNESCO actually mandated the organization to develop an international standard-setting instrument on open science in the form of a recommendation on open science. Of course, we know that this is a consultative process, and it has embarked on a consultative process since several years now, but actually formulated through this particular mandate of the 193 member states and governments of UNESCO in 2019. This was the official process, setting a norm on what is called open science. And the aim was to understand the meaning of open science. I've heard Baron speak about data analysis, data collection, big data, but for us at UNESCO, it really involves the distribution, the use, the methods, but also the peer review, the publications, and how to make it more widely harnessed, accessed, and engagement of all stakeholders. So for us at UNESCO, open science can be a true game changer if only we can bridge the science technology innovation gaps between countries, within regions, to fulfill the human right to the developments of science. And we believe that open science is a critical SDGs accelerator. So here I will just share with you very briefly. I will send you the slides so you will have them. We do think that this is really the appropriate time. So what kind of principles does one need for good data governance, for stewardship? How can you ensure then that you have, let's say, the dialogue, the global dialogue on how to process the raw materials? Because if you are just visiting the data, Baron, I'm not sure how you would process them. And maybe we need some ethical principles then on the processing of that raw data, because it could be processed in different contexts as well. And we need to consider this. So whereas I understand your thoughts, Baron, on data visiting, I think it's important to put in place some kind of protocol and workflow on how you would visit the data, use it, and capture it. I think this is very important for us. So the stakeholders involved in the UNESCO recommendation on open science are educators, research funders, policymakers, the public at large, publishers, scientists, information specialists, and software developers. And you can see here, the key lies in all of you, bringing together this concept of a recommendation of open science and data sharing or data visiting. So I think it's very opportune that we participate as UNESCO in your meeting today, because the draft recommendation on open science has been submitted to the 193 member states actually today for their comments. And we hope to have a meeting in Paris here in May to actually discuss this draft recommendation that's been put together through house-wide and regional global stakeholder consultation. This recommendation was also, I would say, managed by our team here in the UNESCO science sector based in Paris and the regional offices across the world, but also by an international scientific advisory board. Now, it contains a preamble, the aim and objectives of this recommendation, the definition, the core values and the guiding principles. And I think this is where the role of big data would also come in. Then the areas of action and how would one then monitor whether the data is actually shared appropriately. So only just to say that we need to solve complex global problems of humanity, we need to respond to crisis situations, yes, and we have to fulfill the right to science. But then how do you reduce the inequalities? What do you do with data? And how can we make data, I grew up in South Africa and we need to put a face to science. So can we put a face to your data so that the data actually responds to needs of societies? And I think this is where we all have a responsibility towards society and towards the understanding of the use of the data, the metadata. Now, of course, the aim of this recommendation is really to promote the perspectives of open science and to reduce the digital technological knowledge divides between countries. And I'm not going to go into this, but I just want to share with you some highlights of this recommendation, which is distributed to all countries today, 15th of April, and I will make that available to you. While all the parts will differ in contributing to understanding open science, it requires a profound change in cultures and across borders, across countries, but moving from competition to collaboration and from having to sharing and maybe capturing or visiting, as Baron has just informed us. So the aim of this recommendation is really to promote new approaches to open science at different stages of the scientific process, but also to promote collaboration. Now, I will share with you this, but I think this is an important slide because we're talking about data, big data, fair data, but should we have restrictions? Should there be national security, confidentiality? Should there be privacy revisited? Should IPR, intellectual property rights, and at least secret indigenous knowledge on endangered species and even local indigenous knowledge be protected in a particular way? How would you anonymize that data? And then how would you promote the systems thinking? Because as Baron mentioned, every one of these data comes with its own set of rules and regulations, understanding, interpretation, and use. So how would you then promote the systems thinking across this data? I think it's very important. We've seen the systems thinking in the COVID-19. What have we seen? We've seen access to genetic data immediately. We've seen access to data and infrastructure. We've seen the sharing of scientific knowledge, whether it's tracing, whether it's sharing information on genomes. We've really seen science-based decision-making. Now, I think this has been an important demonstration as well on patient data. And I think much more reflection needs to go in this direction as well, because metadata and fair data really involves different boundaries, such as the social sciences, and could involve sensitive data from all aspects. So we believe that we need to bridge these gaps and the gaps between the different knowledge stakeholders and knowledge holders by making it more connected to societal needs, equal fair opportunities, and having the human right to science. But I want to share with you something, and this is real life experience of UNESCO. UNESCO is home to designated sites across the world where we are protecting and preserving our relationship with nature, the coalition with nature. Right now, 260 million people call UNESCO's biosphere reserves their home. They live within these boundaries of preservation, conservation, restoration, and transmission of this knowledge. And so you see that within these biosphere reserves, which actually crossed all different boundaries of data sharing, whether it's scientific monitoring of the environment, local indigenous knowledge populations, impact of climate change, social impacts, cultural dimension. So my question here is, how do we manage all of this now in big data, fair data that UNESCO is trying to put together to understanding how people live in harmony with nature and how can we promote this coalition with nature. We have this tons of data and we're not sure of the crossing over between these boundaries, which raises a lot of ethical problems as well. And here I would like to show you this huge wide landscape of all our protected areas of UNESCO. But these areas contain important information on culture, on geosciences, on biodiversity, on natural heritage sites. So how would one manage all this data across the boundaries in a fair and open data, open access? So I think I would like to have some reflections with all of you. How to ensure this and how to best support countries to access this innovation data for their sustainable development. How to connect these infrastructures. What tools do you need? And what role for fair data in the global response to environmental crisis, biodiversity, habitat loss, pandemics? How can this data provide the baseline for potential solutions? What capacities are needed for systems analysis? For example, for sustainable, peaceful natural resource management. Can we have a reflection on that? And then how do you see the science diplomacy in the open data? How would that fit in the global agenda? What opportunities for integrated transdisciplinary open data sharing? And what tools do we need to measure the impact of the, fair and the open data? Thank you very much. I hope this has started a new kind of dialogue, Baron, on how we could take these questions forward across different dimensions. Thank you.
Thank you. Thank you very much, Jamila. That was an excellent presentation, and I really enjoyed your slides. And I really see the discussion here. So probably we're going to have some questions. Let me see if we have some questions from the audience or maybe from our speakers.
Maybe I would like to get one reaction because of the challenge, of course. And then move on for other questions on all these other questions at the end. I think indeed you have a point that visiting is not enough, and it is probably good to tell you the typical thing that they say about the Dutch. If they say "kom je nog langs" in Dutch, if they invite you to visit, but if you say "do you come langs," it means like you don't actually come in. So it's a very non inviting way to say, "Are you coming along?" And I think indeed, of course, visiting data has a purpose. So I always say, if you look at FAIR, the biggest mistake that I've heard people say is, what's this R all about? You know, it's if you're findable, accessible, and interoperable, you're reusable by definition. No, you're not, because are you fit for purpose? All these things. What is the conditions under which you can reuse it? So I say the final goal is optimal reuse, the R of FAIR is the reuse of the data for the right purpose, locally where possible. And the F, the A, and the I are only submissive to the R. You know, you have to make data reusable. And that's why we even said when people say, oh, if are my data unfair when they're not fair, we say, no. They're just reuseless. And that's a new term. So it is all about the reuse of data, not just the visiting. But the point of visiting is indeed that we use the data where they are and we do not bring them into a stupid big data warehouse in Brussels or something like that. Yeah, that's the
idea. Probably we're going to have a new vocabulary after this with a set of new
data. Most of the data today are reuseless.
Shamila, I have a question.
Yes.
I'm very supportive to this strategy, and I think that's it is very important to advocate this, especially on the high level within their international science diplomacy ministries and government, because scientists, regular scientists, I usually do for what it is counted. So, I mean, they're always evaluated by our ministries. I mean, when I'm like leading the research, I need to publish papers because I'm evaluated by the way how I'm publishing these papers. I'm paying a lot of money to be published, and it's not again, and it's again a PDF as a nightmare for machines, as we know, but this is the way it still goes for 90%. But how we can uh, teach, how we can learn to take care of our data, and to not only to make it open as possible, but also to make it understandable. Because if I wish to use somebody's data, I need to understand it. So people should really take care of it, of the way they produce the metadata, and about the whole life cycle. We can teach new generation, and I'm sure that the next generation will be much better than we are. But can we solve this problem on our current level?
That's a good question, Alena. I think, and I see Baron smiling as well. I must say that this is one of the biggest paradigms of the current context in which we're living in, because we've seen that during, the only reason we advanced so rapidly to identify vaccines and therapeutics was because of the sharing of data. It went beyond paywalls, patents, and publications. It went beyond that. It went beyond funders and donors. It was just simply sharing of information and data. Now, of course, that's a utopian dream. We all know that, coming from research and having worked in laboratories for a long number of years. I know this as well. We know the competition that scientists face internationally, and this puts an additional strain on scientific careers. It's either publish or perish.
Well,
This
because
has been the motto.
but
So
it's very important to distinguish between publishing data and publishing old-fashioned papers.
yes,
I think nobody would contest competition in science, because even in COVID, there was a lot of competition, and it was
yeah,
exceedingly difficult to get to the data, actually, to build the data model
yes,
with, on the side. So I think there is a real point. I always say the worst invention ever for modern open science was the journal impact factor. But the second best is supplementary data, because then people moved slowly on to data rich science, and they say, oh, let's put our data sets as supplementary data and hide them behind the paper so machines cannot find them, and there may be a link, but 30% gets broken every year. So the current publication system for science is hopelessly outdated.
yeah.
We need to publish data with a supplementary article.
Yep. And I agree with you. And I think another problem is that the high impact journals are publishing information and data which excludes automatically the research which is so needed in developing countries. We see all these high impact journals are not publishing on the ground data and information that will be useful to developing countries. And that data is lost. That's because they cannot access the high impact journals. So you don't access the wider community. You don't access the wider funding agencies as well. And this is where I think we need to look further into this. We should not relinquish the principles of integrity of research, of course, in that process. We do need integrity, and we need the highest quality peer review, but we should give value to research which actually meets societal needs, even in poor, small, developing countries. But we don't have that today. So
But
how would that data from the small developing countries be taken into consideration? How would you, as a big fair data, take into account the data of small countries and small island developing states,
well,
which is so essential today to combat disaster risks?
we do
So that's my question.
We
Yeah.
should. The thing I'm most proud of last year in COVID is Vote on Africa. They are ahead of everyone. They have 11 fair data points throughout Africa in 7 different countries, and we can visit them with Sparkle queries, which is way ahead of Europe, you know. So, and they never have to give their African data to the north and never get them back. So this is an extremely important thing. But maybe, and although I hate statements that usually the UN can do, like, you remember health for all by the year 2000? Yes, here we are. But wouldn't it be great to set this statement of George Strawn as a goal for UNESCO? One computer, one data set. including everything for developing countries.
We just
Because
hope that
data
everybody
is global, they are included.
we just
Um,
hope that everybody in developing countries is going to have a computer just to follow the statement, and then it's going to be a truly game changer. So
may I just come in here as well?
yes, and
in the discussion, or just very briefly, I just would like to compliment what has been said, and I think it's really interesting, and there have been a lot of very good points made also with respect to the digital divide to developing countries, and also the mind shift and the need for cultural change has been mentioned by Shamila. I think that's great. But I think what makes researchers in the end change is the incentives. So we need to get the incentives right. And I do agree with Baron that it's not ideal yet. We still have a long way to go, but there are some positive developments on the horizon at the moment. For example, nature data is exactly doing what Baron is saying. Nature data asks for the data is free and open, and you're describing the data, and you're now getting acknowledged for that, and you're getting an impact factor for actually publishing data. And I think this development is extremely positive in this going in the right direction. And other part of incentives is also that funders are now increasingly asking for open data. So they don't fund anymore if the data is not open, if the model is not data. And I think this is the only way to go. The only way we can get this thing done is by changing the incentives, making the funders aware that their funding for SDGs actually becomes useless, simplified, if the data is not becoming available. And the third thing is that we need much stronger legislation also for companies, because as Baron has correctly said, 90% of the data was produced in the last 2 years. And that is actually, most of the data is actually owned by the Googles and the biggies. Let's be realistic. That's what the big data is sitting. But none of it is currently, or very little is in a machine readable form. And this you could even see during the COVID. So whereas Google made the mobility data open, it was in a PDF format, it was not machine readable. So there needs to be some legislation put in place, similar to, for example, a patent. A patent expires after a certain time. Why cannot the holding data be expiring at some point? And I think we need to also distinguish very clearly between sensitive data, which is a patient data. I fully agree with Baron on that, fully. But why can some data, which is not sensitive, not freely flow anyway? And that this is also, I think, a very important point. I just wanted to throw in these thoughts in this current discussion. Thank you very much.
Yeah.
thank you.
Sorry, Alena, if I may just say, I think we have to consider different cultural contexts as well, because what a Western society may consider as non-sensitive data may be sensitive to other cultures and communities, and we're seeing it right now, even during this COVID. So I think it's very important to consider that. I have a question to put forward to you and to Baron. Could you consider the ethics of big data? Or have we ever considered the ethics of fair data and the meaning of fair data and the meaning of open data, or the ethics of open data? I think this is something that needs to be considered as well, because there are different ethical dimensions, different perspectives, and that needs to be taken into account. Even if you have one computer, one data set, based on whose perspective, one computer, one data set, whose one data set? We have 193 member states here, Baron. So help me.
But I think the formal, there is formal rules. Can you own data in the first place? Data as in the non-processed form. I don't think you can legally, at least not in Europe. And everybody now agrees that in principle, the data donor, if it comes to personal data, not only patient data or your movements, your whatever, that are sensitive, you're the owner, whatever that means. So I think what we should really look at is data should be viewed wherever possible as a common public good, because 90% of the data are created by public funding. And even I'm teasing companies like pharmaceutical companies saying, oh, even you deduce your research from my tax. You pay less taxes because you do research, so I pay for the data. There is no reason, unless you have an extremely good argument, to keep data closed.
Mhm. I absolutely agree on this point, and actually, because data is science, and there is no doubt that it is, and science is a global public good. So data is a global public good as well, even if it is my data, even it is the data about my movements, but it's a global public good. So this.
So the vice president of CODATA just decided, and now we're done. Thank you so much.
So and here I wish to make a step to our next speaker today, Christian. Are you with us? Christian, responsible for the strategy development of the European Union policies for smart infrastructures, Director General for Communication Networks, the European Commission. Christian, I'm happy to show your slides.
Perfect.
Okay, wonderful.
Alena, thank you for giving me the floor. So my name is Christian Kirchsteiger. As Alena said, I'm coming from the, let's say, the digital branch of the European Commission, which is called DG Connect. And specifically, I'm coming there from a unit which interestingly has the title Open Science and Digital Modeling. And this is interesting for many reasons. One of them related to this event, because it somewhat shows the spectrum with the two things, open science, digital, and modeling. If you allow me, on the two extremes of the spectrum. And what I would like really to talk about in this brief introduction, and then hopefully have a discussion, is about the common denominator, which very often doesn't exist, unfortunately, between these two extremes, and that is quality. And quality in the sense of accountability and actionability. And I am, well, first of all, please bear with me that you do not see me, which is not because you would be frightened, hopefully not, but because the connectivity is extremely bad. So let's hope that the audio at least works, which is an irony in itself, because I'm coming from the digital branch of the Commission. So you see the basic problems of connectivity, but that's another story. What I'm really would like to talk about is the issue of quality in the sense of actionability in the context, of course, coming from the Commission, from the European Commission, in the context of using science for evidence-based policy making. This is it all about. And in that sense, I would like to talk about the limits of open science with the usage of scientific results for policy making. Which sounds a bit like a contradiction if you look at the policy goals, or one of the policy goals of the institution where I'm coming from, namely open science. But it's really more like a call for realism, and hopefully not a desperate one. So the next slide, please. So as you know, there was and there is a lot of support from the European Union on open access or open science in the broader sense. And I do not want to go into any details. I mean, I'm sure you are well aware about that. So all the projects under the research framework programs of the European Union are, for example, required that peer-reviewed articles are openly accessible, free of charge, and so on, including a provision on data, which is a separate issue, but let's not go into any details. There are recommendations on this. There is kind of instrument in the making, I would say, which is the so-called European Open Science Cloud, to support exactly this transition towards open science. And there is there are a lot of EU projects on the implementation on the national level. A little note: unfortunately, the implementation is sometimes linked this is my private opinion, to the availability of funding for such projects rather than linked to the actual necessity or possible necessity of the issue as such, but it's another story. The next slide, please. Just to look a little bit, but this just for 2 sentences, the history of research dissemination. I mean, again, without going into any details, it seems to me that we are a little bit back after 3 centuries in the pre-Newton time, where essentially you have to pay something to have your finding printed. The big difference, of course, is, as we all know, that the abundance and overabundance to a large degree also of information is the new phenomenon. And therefore, and now I'm really coming to what I really want to talk about, therefore the issue of quality and accountability really moves into the centerpiece. And this is not a philosophical issue. Well, it's also a philosophical issue, if you like, but it's becoming very much a practical issue. And I'm not talking from a philosophical viewpoint, but I'm talking from a very practical use case viewpoint, because the little propaganda which I sent around a couple of minutes ago in the chat, this link, is an initiative, a rather large initiative, which is starting now, so to say, in these months, a large initiative of the European Commission on the, well, on the classical support tool infrastructure, decision support tool infrastructure for science-based policymaking, in this case on the implementation of the so-called Green Deal. So all the world of sustainability issues and related policies, and how are they implemented. And for all that, we're aiming at developing scenario building tools or an infrastructure of such tools and data for practical, really practical policy developing and policy implementation and monitoring purposes at the European level, but also for the member states, of course, on a national level. And this is the link, of course, to system science. This is the link why our service, I suppose, has been invited to this distinguished event. And here, of course, we come up with the issue of actionability of all these results, and how does that link to, for example, to the calls for open science and open access. So all I would like to really emphasize is the next slide, please, which already is the last one, the next slide. But this is really the centerpiece, what I would like to talk about and then ideally discuss about. So I would like to emphasize that all these nice principles of data transparency are, of course, subject to limits. The prime reason is that concerns about data falsification, erroneous analysis, and misleading presentation of results have recently strengthened the call for new procedures that would ensure public accountability for data-driven decisions. So I'm generally in favor of increased transparency in data practice. I would really like to remark that some legislative efforts that invoke the language of data transparency can have very different interests and political goals in the background. So framing these, let's say, political games in the language of transparency can, on the one hand, be strategically quite clever, because approaches that emphasize open access to data, for example, carry nowadays tremendous appeal, particularly in current political and technological contexts. But as I said, I mean, data transparency can be used to advance not necessarily the goal of objective quality, but in a sense also to paralyze the decision-making processes of a regulator. So for example, if you consider that more or less each policy service, policy directorate general of the European Commission, especially in the environmental and sustainability domain, relies on, I do not know the number, but let's say on dozens or hundreds or whatever of scientific and technical studies annually to make policy decisions. Obviously, a full transparency of access to data, let's say, would severely restrict the ability to actually enact regulations due to both the costs of making such data available and of course the fact that certain classes of data are impossible to release, as was indicated by one or two of the previous speakers. So really all I want to throw into the ring now for feedback from you is I think the realization that there are clear limits to transparency, and especially for science-based policymaking. And I can see at least three, as shown here in this little list of bullets. I mean, the first one is the classical one, which was mentioned before also. I mean, privacy security concerns. The second one is the one which I mentioned before, that open.
We can't hear you anymore, Christian. Sorry.
No, you broke up. Yeah.
We missed you. Christian, can you hear us? Okay. Okay. As I know for sure, that was our the last slide that Christian wanted to present to us. So just to save our time, I see that Christian probably has some problems with connections. So just as a moderator, let me suggest we move to our last speaker now. And then we hope that Christian will be back to us and able to participate in the discussion, and we can then ask some questions. Stefan, he's program director of the Strategic Initiative Programs from IIASA. So we're very looking forward to your talk, and to probably you can share with us current IIASA practice in data stewardship. Stefan?
Yes, thank you. Thank you very much, Alena. Nice to meet you all again, and nice to have this good discussion with you. I'm very much enjoying it. I think it's really needed and it's really important. Maybe just a very quick remark, if you may allow me.
Can you just give me the chance to finalize the presentation, because I was kicked out, and I hope I'm back for at least 2 minutes to come to the actual thing I wanted to say.
Sure.
Yes. Sure.
If we go back to the previous presentation and the last slide, the last it's just about the last bullet point. One back. Because I mean these first two limitations which I mentioned. I mean, coming from a digital unit, I suppose this with all the nice buzzwords of artificial intelligence and everything, this will be or might be ameliorated over time with technology, simply saying. But the critical point is the third one, and this third limit seems to remain, and that is simply the fact that epistemological limitations and really deep uncertainties will probably always constrain data-driven political decision-making. And in my belief, and I'm very interested to engage in a discussion, no technology can help here. So policy institutions charged with, for example, protecting health or the environment must make decisions in the face of deep scientific uncertainties, and simply because science by its very nature is incomplete and only very rarely gives somewhat precise answers to complex policy questions. And so the only solution which I can offer here is that scientists working in policy institutions should delineate the extent to which their science policy decisions inevitably are informed by value judgments, that go well beyond science. However, to my great dismay, I cannot give you a single example when that would have actually ever taken place in practice. And with this, I would like to go in a discussion, and I very much hope to be refuted with my arguments. And the real reason why I'm talking about all this is exactly mentioned here, which is our EU Green Deal implementation initiative, so-called Destination Earth, which is hopefully becoming a very nice infrastructure, pan-European infrastructure on decision support tools for sustainability policy issues, policy making and implementation issues, and a key issue of actually implementing this infrastructure after having solved all the technological issues, all the IT things, which is rather trivial, I would say, compared to a key issue, which is exactly the one on the actionability, on verifying the actionability of predictions, for example. And this links very much to open science. First, because it's the limit, but also because if you look at the type of data which could potentially come into such an open infrastructure, because it's supposed to become an open infrastructure, such as, for example, citizen science, then clearly the issue of quality in the sense of actionability moves into the center, I think. And for any suggestions to deal with such issues, we would be more than interested to engage in a discussion with whomever. And the floor is open, if I may say. Thank you.
Thank you very much, Christian. Thank you very much. So in the interest of time, we can have a short question here or save some time for wider discussion after our last speaker today. Do I have an immediate reaction right now? Probably some.
I do, but
Yeah.
better to do it at the end, I think, because
yes. Let's do it at the end. I think thanks a lot, Christian, for these very interesting, quite provocative points you brought up. So maybe let's keep that for later. I have a few thoughts on this, and I think it's really interesting to work on that discussion. But maybe since you brought up the term, maybe I very briefly share also my screen. I have some quick kind of presentation as well. I can try to show you. Let me see if this is it. Can you see my screen now?
Yep.
Yes. So I just want to bring us back to what Shelima also has raised initially, and this is the relationship of big data and open data and fair data to the big challenges we are facing. This is the Paris Agreement, the Sustainable Development Goals, but also the Sendai framework. And we are, of course, I think all in the same boat, knowing that if we are not using the best technologies, artificial intelligence, we are not going to bend the curve. So we've heard the bending the curve argument already. And I think this is our one of the biggest challenges we are currently facing. So just coming back to the land use sector, which actually can sequester and can play a role in terms of 25% contribution it makes to reaching the Paris Agreement of the 1.5 degree target. We must peak emissions in 2020. We must go down and achieve zero by 2040, 2050 latest. And this relates a lot to behavioral change. Without behavioral change, we're not going to reach the 5 to 1.5% goal, which relates a lot again to understanding people's behavior, understanding how we can reach, for example, dietary shifts, but this means to deeply understand certain behavioral patterns in terms of consumption and also in terms of waste. You see it here, there are lots of points where we need to make progress, where data and big data of humans is highly necessary and required, also to understand if policies are actually feeding to fruition and being properly implemented and followed by the people. We know we have big data gaps, especially in the land use sector. A lot of data is still not there, even though we have more and more satellites. We still have very little about crop management. We still have very little about and how much marginal land is there globally. And I just want to show you one citizen science, so this relates. So thank you very much for the previous speaker bringing up that topic, how good, and the big question is how good is citizen science data? And I would say it can be good and it can be very bad. It depends a lot on the question, what you ask citizens to do and how you design your crowdsourcing campaign in this case. In this case, we just asked people and we trained them, we gave them feedback. So it's not just a one-way communication, collecting data from citizens, but constantly giving citizens feedback about the quality, checking the quality, having several people looking at the same spot, in this case, very high resolution images, just asking the question, do you see fields in this image? 90% of the people would actually be able over time to answer these questions with very, very high accuracy. So that's why I'm actually very confident that citizen science can contribute really very high level and good data, as well as I see the point. There are also question marks on the uncertainty in some cases, and we need to really differentiate that. But in this case, we have managed to downscale this initial large land reserve of land availability with the citizens campaign and show there's actually much less land available to grow biofuels in this case, where also the biofuel lobby was not very happy about these results. And these are just some other citizen science campaigns we've been doing at IIASA. This is another example where we mapped poverty in Senegal and where we demonstrated that mobile data is actually really, really useful in getting a better picture. For example, the top-up rates people use in the country is a very good indicator also on poverty-related issues in terms of food security-related issues and tackling some of the food security-related SDGs, in particular number 2, for example. Just to show you that there are very, very interesting connections you can derive from big data. And sometimes it's not intuitive that actually how people search for seeds in the US gives you information about crop calendars. So when is actually the sowing time? This relates very much to how many searches you get and in what month of the year. So I just want to show you sometimes there is some counterintuitive data out there which makes you conclude very, very new interesting insights. That's just the point I wanted to make, and I just show you a few examples also from IIASA's research in this context, and maybe we want to now open the floor for discussion. Thank you. Thanks a lot.
Thank you, Stefan, very much. That was very interesting, and I was really impressed with all these data sets presented from and on behalf of IIASA as well. And I think that we have actually we had a great discussion even throughout our session, and was very happy to moderate this. And let me now have just some time. I know we were running a bit late, but I think it's very important for us. Just speaking in the words from Shamila talk, looking for their game changer. So what is our game changer that we can identify here after all this experience in data practice that we heard today from our speakers? So so I think that we have some questions to Christian as well. Shall we get back to this discussion and continue for save some a couple of minutes and to share our view on how we can solve those issues identified.
Before we move there, Alena, I think one thing that I also saw, we have to get our definitions right. And in Christian's presentation, the term transparency came up, and we have the term openness, and we discussed ethics and so on. And what irritates me a little bit in the discussion, not here, but in the global discussion, is that open is then associated with the good guys and closed with the bad guys and so on, you know, while it's all about treating data, specifically data that are useful for research, as a global public good. Okay. And I said there is even no argument to say, oh, I paid for the data myself as a company because you deduce your research from taxes. So it's a global public good. And I think the first thing we really have to get to is to this abuse of the term open. Because open science is not about throwing everything out in the open, also the data. It is open protocols, transparency in how you got to your conclusions, reusable workflows, open data where possible, as close as necessary. So I think we really move, as I think Stefan said in the beginning, we have to move beyond fair. Fair doesn't say anything about data quality, about fairness with small letters or anything, or ethical things. It's just saying the data are machine readable. So I think the next step is that we require as open as possible, as closed as necessary. That's already a slogan in the Commission and the European Commission. But I would add another one, as distributed as possible, as centralized as unavoidable or as necessary. Because coming back to the African situation, if we go back to the Ebola epidemic, all the data are now with the donors in the north, and the Africans cannot even access them anymore. But in the fair data points that we now have in COVID, the data never leave Africa. And right now we are even in a localization process of CDAR from Stanford, because we say, okay, it's good to make the metadata templates on the server in Stanford, but we are not going to send the African data to Stanford and back, even not if they go back to Africa. They say, no, no, no. These personal data will never leave the country. The moment they're in the United States, I don't trust them anymore. So equity and treating data as a global public good and having additional basic principles that UNESCO and the EC and so would promote, I would suggest as open as possible, as close as necessary, as distributed as possible, as centralized as unavoidable.
Thank you.
If I may just quickly respond to that. No, I mean, I like all these slogans and I fully underwrite all of them. But again, it's in our very specific little world, it's an issue it's an issue of practicability. And what we are actually aiming at is really a definition of actionability of information, which is one aspect of quality, of course. And actionability in the sense of, or actionability applied to, let's say, to predictions, to knowledge coming out of modeling efforts, which is based on all kind of different types of input data with all the different quality aspects. But there's also the internal mechanism of the modeling approach, which further influences the basic or the input uncertainty, let's put it that way. And to integrate all that into whatever, an index, naively saying, on quality, actionability, this is, I think, the real challenge. And all this has not been a great issue in the past. I mean, talking about the digital twins, which I think Barend mentioned in the beginning in his medical applications. I mean, the quality aspect, I think, of physical systems is not so much an issue because pretty soon the quality will reveal itself simply by reality. In the case of model predictions, long-term predictions, let's say about climate change, to take the extreme, the effects are supposed to be observable only in decades or even longer. And therefore the issue of being able to determine or assessing or narrowing down in a sense the actionability of the prediction is really an urgent issue, because it has tremendous social and economic, which then again is social implications.
Thank you very much. I think that we're now concluding our session, and I wish to again thank you for your presentations, and that was an excellent discussion, and which one I personally really enjoyed. And I think that if we could have time, we could, it's especially if offline, we could speak for a couple of hours after. Just my conclusion will be that we should be very precise in the way we produce our data vocabulary and the way we make these definitions, because people are still very sensitive to open data, to big data, and it's still not always clear for data producers how they need to manage their data, and we should look at this on very different layers. So from their top layer, where we have their decision makers, and where people can evaluate signs by the way they treat their data, the way they produce their data, but also we should take care of data ethics. I think that's extremely important point, because we should be aware that we're living in a big world, and not every scientist is already ready to make their data sets AI ready. And we should, so I think that I'm looking forward to game changer. I really like this from your presentation, Shamila. So I think that our game changer is systems approach. Just try to, at every moment, to consider all the specifics of the way we promote data. Data science. So let me apologize that we just a bit running a bit late, but not much. So, and I'm just now giving back the stage to the organizers to make the final session and closing remarks. Thank you very much.